Do some more sample problems. So I've got two more of these sample problems, and we're going to see that some slightly different things happen on these problems as well. We're going to do the same approach, making our rice table. And after we make our rice table, we need to stop and think about the algebra for a moment. Okay? So let's do that. So in this problem, so suppose for a synthesis of hydrogen fluoride from hydrogen and fluorine, 3 moles of H2 and 3 moles of F2 are mixed in a 1.00 liter flask. Assume that the equilibrium constant for the synthesis reaction at this temperature is 1.15 times 10 to the 2. Calculate the equilibrium concentration of all species. Okay, so first we've got to do R for a reaction, right? We're doing our rice table. Rice it up. Okay, so we've got to turn these words into a reaction. So suppose for a synthesis of. So that means hydrogen fluoride is the product. We're trying to synthesize it. So from hydrogen and fluorine, so that means we're making it from molecular hydrogen, H2, plus fluorine, F2. And those are in equilibrium with HF. And since we weren't given any way of balancing this thing, I'll just balance it with 1 hydrogen, 1 fluorine, and so that means I need 2 HF to make that all balanced. Okay. So there is my R. Let's get our grid going here. Okay. So now we're ready for I, our initial concentrations. So it says 3 moles of H2 and 3 moles of F2 are mixed in a 1 liter flask. So 3.00 moles in a 1.50 liter flask. So hopefully you can see that that's going to be 2.000 molar. Okay. So it says, gives us concentrations for hydrogen, and it gives us concentrations for fluorine, but it doesn't give us any concentration at all for HF. So when that happens, you assume 0. If there's no concentration, initial concentration of one particular species mentioned, you can assume that it's 0. Okay? So now this is actually going to make calculating our change column pretty easy because if this is 0, this has to be a plus X. Okay? It can't decrease from 0. It has to increase. And also, this is the first time that we're seeing some stoichiometry. So we've got this 2 in front of HF. So that means this has to be a plus 2x. If this was a 3 in front of HF, we'd have to say plus 3x. So that coefficient is going to get our stoichiometry correct. Okay. And so for H2 and F2, there's 1 and 1. And because the product increased, that means the reactant has to decrease. It has to, okay? And so now for my equilibrium column, let's see if I left myself enough room, just barely. So that means at equilibrium, this will be 2.00 minus x. This will be 2.00 minus x. And this would just be 2x. I could say 0 plus 2x, but that's not necessary. So now we can set this all equal to our equilibrium expression, which we know was 115. So that's the same as 1.15 times 10 to the 2. Okay, and so that all equals, let's just get this equilibrium expression. So that's HF. But we remember, because there's a 2 in front of there, we've got to say squared. Okay, divided by H2 times F2. Okay, great. And so now we can plug all this stuff in. So we can say 115 equals. And so now we want to plug in 2x into HF, but we remember that this is squared. And so I know that feels like it's going to be double jeopardy, but it's not. Okay, so we've got to say now for HF, that's 2x all squared. Okay, so we're just plugging in the value from our E column directly into the brackets. So that's got to be 2x all squared. And so now this one's 2.00 minus x times 2.00 minus x, which you can see that's going to be 2.00x squared. I just wrote it out there to be complete. Okay, so now let's simplify some of this algebra. So now I know I'm going to just keep it as 2x all squared divided by 2.000 minus x squared. And I'm doing that so that I can think about this algebra a little bit and ask, do I need to use the quadratic equation? And it turns out I don't. I can do another similar trick as to what I did last time. I can take the square root of this side, and I can take the square root of this side, and let's follow that along here. So the square root of 115 is 10.7. Let's see here. Yep, we'll just keep it as 10.7. Okay, and that equals, and then now the square root of 2x all squared is just 2x, and the square root of 2.000 minus x squared is just 2.000 minus x, okay? And so you can see, once again, this is going to be a pretty straightforward problem to solve. So I'll multiply the top and the bottom. So that's going to be 10.7 times 2.00 minus x, all equals 2x. So we can distribute that through. And 10.7 times 2.000 is 21.4. And then 10.7 minus x is minus 10.7x equals 2x. And so I'm going to add that over to this side. So now I get 21.4 equals, that's going to be 12.7x. And then now x equals 21.4 divided by 12.7. So let's see here, 21.4 divided by 12.7. So I get that x equals, with 3 sig figs, 1.68. Okay, so now we just plug the value of x back into all of this stuff. So for example, HF is going to be 2 times 1.68. Okay. And so let's see. Yeah, okay. I'm looking at my cheater notes and I'm like, what did I do wrong here? So x is 1.68. Yes. So 1.68 times 2 equals 3.37 for HF. And then that means H2, we know that H2 and F2 are going to be the same concentration at equilibrium, so I'm just going to write it like that. And that's going to be the 2.000 minus x, 2.000 minus 1.68. And with sig figs, we're only going to use those 2 decimals because it's a subtraction rule. So that's 0.32 molar. So I'm going to box those off, and of course, we can also check if those are the right equilibrium concentrations. And to check if these are the right equilibrium concentrations, you know, I need to plug it back into this expression up here. So let's make sure that that works. So that's going to be 3.37 squared divided by 0.32 times 0.32, which is 0.32 squared. Okay, so let's see, that's 3.37 squared divided by 0.32 squared equals, and once again, we got close enough that that's good for me. Okay, if you're like super anal and you want to nail that 115 right on the money, you know, we probably could have carried a few extra sig figs through there. Okay, and that would have given us a slightly better answer. But this is okay by me. Okay.